Namaskar, welcome to PK's classes. Today we'll study enteric coating. So coating is nothing but a covering layer. You can see here, this is the non-coated tablet, whereas this is the coated tablet, and see the improvement in the appearance of these coated tablets. In addition to improvement in the appearance, there are several other properties, and accordingly we have different types of tablet coating: sugar coating, film coating, enteric coating, press coating, and other specialized coatings. And today we will discuss about this enteric coating. So enteric coating actually provides a barrier. Using a polymer, we provide a barrier to the oral medication, mostly tablets. In capsules also we can use this technology. So what is the objective? To prevent the tablet from dissolving and disintegrating in the acidic environment of the stomach, and we prevent its dissolution in the stomach, disintegration and dissolution in the stomach, and we want the drug to be readily dissolved in the alkaline pH of the small intestine. That means this coating will protect the drug in the stomach. So this is enteric coating. After the stomach, when it reaches the small intestine, there it will be released. That is the objective. So how we can do that? The mechanism: the polymer which we use, that is insoluble at low pH, that is the stomach pH, which is 1.5 to 3. At this pH the polymer is insoluble, but it becomes soluble at the higher pH above 5 in the small intestine. So you can see this is a polymer used as the coating material, eudragit, which remains intact in the stomach, whereas in the intestine there will be, when it comes in contact with the intestinal fluid, there will be swelling and rapid dissolution of the coating, and the drug is released. So in the stomach it is protected, in the small intestine it is released. So this is the mechanism. So whenever we are using the enteric coated tablet, it should not be crushed or cut or chewed, because that will compromise the purpose for which it is used. So the common examples of enteric coating drugs: the proton pump inhibitors, which are quickly inactivated in the acidic environment of stomach. So proton pump inhibitors like omeprazole, we use enteric coating. So the omeprazole capsules inside the granules are enteric coated. Then some of the drugs are there which can cause stomach irritation. So mostly the pain relievers, painkillers, the NSAIDs, non-steroidal anti-inflammatory drugs like aspirin, ibuprofen, so they can have an enteric coating to reduce the risk of stomach irritation. There are certain antibiotics like the macrolide antibiotics, erythromycin, and nowadays we are commonly using this azithromycin. So these antibiotics are sensitive to stomach acid, and so we can use enteric coating to protect them. Then some pancreatic enzymes which we are using, they also need enteric coatings, because we want these pancreatic enzymes to be delivered to the small intestine. We want their action in the small intestine, so we protect them in the stomach. So for this purpose we use this type of products. So these are some of the examples. So the ideal enteric coating material should be stable in the stomach pH, whereas it should dissolve in the small intestine. That means when the pH is less, 1 to 3, that is in stomach, it should be stable, and at higher pH above 5 and above, it should dissolve rapidly. So that is an ideal enteric coating material, and typically they are synthetic polymeric polyacids. And let us discuss some characteristics of ideal enteric coating material. First thing, it should show resistance to gastric fluids. That means it should remain stable at low pH, pH 1.5 to 3. It should be soluble in the intestinal fluids. That means it should be soluble above pH 5. So the pH sensitivity should be there. Then it should have some film properties. It should form continuous and uniform film with adequate mechanical properties like flexibility, durability to prevent cracking or damage during manufacturing and storage. Next, it should be compatible, highly compatible with the drug substance and other coating additives like plasticizers, coloring agents and other solvents we use. It should be compatible with them. Then it should be non-toxic and it should be inert. It should not have any pharmacological activity. And from the manufacturing point of view, it should be easy to apply using a standard coating equipment. For example, spray coating in a pan coater or fluid bed coater without requiring specialized machinery. It should be easily manufactured. So the common enteric coating polymers are methacrylic acid copolymers. Example, Udrazit. This example already we have shown. Then cellulose acetate phthalate cap, hydroxypropyl methyl cellulose phthalate HPMCP, polyvinyl acetate phthalate PVAP, and hydroxypropyl methyl cellulose acetate succinate HPMCAS. And these polymers often require the addition of plasticizers like triethyl citrate, diethyl phthalate to improve film flexibility and reduce brittleness. So this is a picture of enteric coating with shellac. So this is an example of enteric coated pantoprazole, the proton pump inhibitor with domperidone. Then this is how this enteric coating tablets look. So the purpose and benefits: the enteric coating provides protection to the drug. So the drugs like antibiotics, as we have already discussed, the macrolide antibiotics like erythromycin, azithromycin, they are protected because of enteric coating. Enzymes which need to act in the intestine, pancreatic enzymes, they are also protected due to enteric coating. Then we want to get protection from the irritative effects of non-steroidal anti-inflammatory drugs. So protection of the stomach can be done by enteric coating, because these NSAIDs like aspirin, they irritate the stomach, so we can use enteric coating to protect the stomach. Then target drug delivery. Sometimes we want our drug to show its action, the local action, and at the intestine, not in stomach. For example, anthelmintics, amoebicides, they show their action in the small intestine. So we can use enteric coating so that they can reach small intestine and show their action. And the pancreatic enzymes also, we want them in the small intestine, so that is already discussed. Then some drugs are absorbed better in the small intestine, so for that also we can delay the release of the drug by enteric coating, so that it will be released in the small intestine, and since absorption is better there, that drug can be available there, and then absorption can be followed. So this is all about enteric coating. Thank you.